Recording is on.
All right, computer networking. Uh, this should not be a strange topic to most of us, right? So we can just assume Okay, okay. So there's a note there, right? A must have. A must have for software engineers and data professionals, specifically data engineers. I guys get it. Okay, let's continue. What is computer networking? So, networking is the practice of connecting computers, servers, or devices so they can exchange data and resources. Hmm? The most common network um, networking concept that we know, or let me say network. The most common network that we know is the internet, right? The internet is a network of different devices all around the world, right? Mm. I go to my WhatsApp, the only reason why I can send a message to someone who is maybe in US is because it's connected to the internet, right? Okay. Think of networking as the roads and highways of the digital world. Data travels from one place to another following roles and addresses. Key idea: any application, API, cloud service, or distributed system relies on networking, even if it feels local. That's very true. Okay. Real world analogy: nodes are equivalent to what? Houses or buildings. Hmm? Links equivalent to what? Roads connecting the houses or buildings, right? Data, these are the packages being delivered between these houses or buildings. Router is the traffic director. Switch, intersection connecting multiple houses, like the junctions, right? Exactly, the analogy is it. Okay. Why networking matters? For engineers, networking is not just IT stuff. Because when people hear network like that, just they don't really ever pay much attention to it. But at the end of the day, networking affects all of us. All of us. I mean, as a software engineer, sometimes you be like, "There's no network, I cannot work this." I mean, but that's just the internet, right? But you start right down to even your computer system itself locally, it functions based on networks. So software engineers, API calls, client server communication, microservices, latency issues, like there's a delay in maybe you sending a request and getting a response. Networks, how are you going to fix that? You said you can even start feeling you don't even know anything about networks, right? Hmm? Okay. Data engineers, cluster communication, data pipelines, streaming systems, distributed storage. Cloud engineers, security groups, load balancing, interregion traffic. fact, there's networking everywhere, 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 and the architecture of most of our programs and a lot when it comes to, because at the end of the day, everything is kind of connected to the internet, right? So that already makes, like, ensures the fact that okay, you need to use what all these networking protocols and everything and all whatnot. So even if let's say you're deploying an app or you are using an API and all those kind of stuff, if it gives you like an error or whatever, you want to debug it, you start seeing that you have to know all these networking things. Okay, core network components. Nodes. So I said nodes are like the houses or buildings, right? These are the devices connected to a network. Your laptop, your mobile phone, your TV, your tablet. So computers, servers, mobile phones, IoT devices. Any endpoint in the network is a node. It will be a smartwatch. It will be a fridge. So fridges are connected to the internet. Really? Or to a network. Well, let's not talk about internet, guys. Like smart houses, everything's interconnected. Yeah, just in your house alone. Yeah. Even the gate is a node. Even gate is a node. It has like even that stomach sprinkles water is a node. Of course, some people like are they connected somewhere, have to go and be on it and all this stuff. So it starts sprinkling water. I mean, we are doorbell. Like, I mean, everything. They have links now, medium through which data travels. So it can be wired or wireless. You get it? So wire, we have Ethernet cables, right? We have fiber optics, which most of our networks use, right? Optical fibers. Wireless, Wi-Fi. I mean, we're using it right now. Cellular, make your calls. Bluetooth, we use Bluetooth, right? Those are links. Then devices now. The different devices can be routers. So routers connect different networks and as such it directs traffic. So I have a home router, AWS VPC router. Okay. Switch function. It connects devices within the same network. Are we there? So router, different networks, right? Like we'll build our network here. This we're in the same network. If we want to connect to a different network outside, so let's say our the Starlink or whatever is there, it connects us to another network which is the internet, right? Mm. It needs a router now to go to that other guy. Are we there? Of office network switch. Okay. Modem converts digital signals to internet ready signals. So we have cable modem. Then firewall, it controls traffic. Yeah, that's it. Whether you're allowed or you're not allowed from it, you can access control. Yeah, whether you should access this particular data or platform or not. Okay, load balancer distributes traffic. Nginx, AWX, ELB. So distribute traffic. You know what I mean by that, guy? So we have several servers, right? Okay, this one is exhausted. People should instead be using maybe server instead of this one. So balance the load. Types of networks: PAN, personal area network, just within few meters. Bluetooth, Bluetooth headsets, like when I'm using my headset, right, connected to my laptop or to phone, local area network, office, home. So corporate Wi-Fi or Ethernet. So it's like let's say our Wi-Fi. No, I think that one can go right. Local area network. Metropolitan area network. So within a city. So ISP, Internet Service Provider network for a city. Yeah. Mhm. One, wide area network, global. We have our internet, right? IP addresses, computer identity. So an IP address is a unique numerical identifier for devices in a network. Analogy, your home's postal address. So the internet uses IP addresses to identify a node in the network. Are we there? So we have IPv4, which is the most common. So I think you guys have seen something like this right before. And they will have IPv6. It's really long. Future proof as IPv4 addresses are running out. So there's so many devices, so many nodes now on the internet that these IPv4 addresses are being used up all. So now we have to start switching to IPv6. You see how long it is. You can imagine I mean, how many billions of nodes can use it. So it's not about the people, right? It's about nodes. One individual can have like exactly. Types of IP addresses. We have private, which is used within local network. We have public, visible on the internet. We have static, never changes. We have dynamic, assigned temporarily. So DHCP, that is Dynamic Host Configuration Protocol, that's the protocol which aids in assigning IP addresses, right? These temporal ones, like you just log into get into the internet, they give you the assign an IP address for you. Once you're done, you log out, right? That IP address is taken and assigned to someone else. Ports. Now, ports. Okay. Service channels. So a port identifies a specific service on a device. Are we there? A port identifies a specific service on a device. IP, where the device is. Ah, okay. IP is like the address, right? Like we said. Port, which service on that device. So the IP is how the internet knows your laptop. Why the port now, like it's within your laptop now, you have different services, right? So the port is now how your laptop knows maybe a particular service or recognizes a particular service. Hmm? Now, if you want to stop a service, you could just give it its port number. It stops it. Examples: HTTP port 80, HTTPS 443. So you're asking the port, are just numbers, right? But from it, you know, okay, that's SSH working there. That's the SSH service. That's the HTTPS service. That's MySQL service. That's PostgreSQL service. So these are different services. We're going to actually see them, man. This number, I'll just say 3,000. Now that's React.js. 8,000. That's Fast API. 5,000. That's Flask. So those are their default ports. So she will now, okay, if port 5,000 is running, I'm like, oh, Flask. If port 22 is running, I'm like, okay, SSH is running somewhere. Okay, that will calm them. Should I be like, people have to calm this stuff? No. Well, when you guys start using them, you just you get used to it. Yeah. If your IP is your home address, the port is your apartment number. Mm. So in my computer, I have different apartments. Yeah. Protocols. So protocols are rules of communication. Protocols define how devices communicate, including format, delivery rules, and error handling. Important protocols for engineers: HTTP slash HTTPS. I'm sure I've seen this before. Hmm? So it stands for what? Hypertext Transfer Protocol. Then the S here stands for secure. Okay. What is that? What's that? Okay. So its purpose, it works on what? Web pages, REST APIs. So we're going to swarm by REST APIs, web pages as well. I mean, you guys should know what web pages are, right? We go to a web, or you go to your browser, right? You search for something, you visit the web page, right? TCP, Transmission Control Protocol. So its purpose is for what? Reliability, ordered data transfer. So that obviously tells you that what? Not every service is going to use all of these protocols. But if maybe you need this particular thing, then this is a protocol that handles it. This means this is a protocol that you have to maybe integrate into your app or whatever service you're building. Is that clear? So UDP, user datagram protocol, fast, well, unreliable transfer. So if your focus is more on speed, right, than reliability, you want to go for UDP and not TCP. But if your focus is more on what? Reliability now, then you go for TCP, right? Hmm? Yeah. Like reliability and order. Yeah. DNS, domain name system. So it converts domain names to IP addresses, like a phone book for domains. So when we put google.com, we know that what? The internet recognizes nodes through what? IP addresses. So when you put google.com, the internet doesn't know what google.com is. Like when you type something, like what happens? You have to go and fetch the resources for that thing which you're looking for. You get it? For you to know where to fetch, you have to change whatever you have written there to something that it can interpret. So you put www.google.com, you have to change that to what? An IP address, which will go to that IP address and fetch, yeah, pick it up and display it to you. That's clear, right? So the DNS or domain name system helps do what? Convert those names to IP addresses. So it's there like a phone book. Maybe go.com, you see that 192 dot this and so on. FTP, file transfer protocol. So yeah, like you say, it's for file transfers. SSH, secure shell, for secure remote access. Remote access, as in I can be here accessing a server. That's remote, right? Yeah. Now this one is secure. This is telnet, still for remote access. But there are many others, right? This is just a few that were picked out here. TCP versus UDP. Reliability, yes, no. So TCP is more reliable, right, than UDP. Ordering, so there's order in TCP, but there's no order guaranteed in UDP. Speed, slower, faster, obviously. Use cases, APIs, databases, streaming, real-time apps like WhatsApp, making a phone call, right? That should be UDP, right? Because the focus there is on speed. If I say something, the other guy should get it as fast as possible. Mm. We don't really care. Our focus is not about the reliability of it. I mean, you how can I put it? You will not appreciate the fact that the person's whatever the person is saying comes in order if you have to wait like 2 minutes before you get what the person is saying. I wonder when the person say hello, I can get hello at once. Even if he has some kind of break, but I'm getting that, yeah, the person is speaking, is saying something. So speed is what matters for streaming platforms too, right? If I'm getting something over the internet, watching a video over the internet and stuff. Yeah, YouTube live, right? And to see at once, speed. Mm, then this one TCP databases, APIs. Yeah, for that one you want a particular order. DNS, domain name system. DNS converts human readable names into IP addresses. For example, user types www.amazon.com, browser uh, browser asks you DNS server what is the IP. DNS returns the IP for Amazon.com. Browser now uses it to do what? To connect to the server. That's clear, right? Why why is it important for engineers? Debugging. Debugging server unreachable errors. Yeah, you get several errors and stuff. So you should be able to know why is it not reachable and stuff like that. Like there's some errors that once you see, you just know that, oh, I'm not connected, my data is finished. Right? Exactly. So all of those things. Microservice, service discovery. Yeah, because microservices have to, the way they communicate is through a network, right? Cloud infrastructure setup. Cloud is the internet as a whole. So obviously everything that's network inclined. Client server model. So client server model, we're mostly going to be seeing this, especially we software engineers, always antenna. So definition, client. Yeah, client request data or services. Then server responds to the request. Examples, a browser acts like a client, requests data or services from a web server. Are we there? Web server can be anywhere around the world, but your browser is the one in your laptop or your phone. When you type maybe Amazon.com, it has to request the information that you're going to receive from a server, a web server. Are we there? Mobile app, API server. Spark driver, worker nodes. So I mean you're seeing client, server. Client sends the request, the server sends the response. Exactly. Almost all back-end systems follow this model. Yeah. Yeah. Almost all back-end systems. If you have front end and the back end, the front end acts as a client, the back end acts as the server. Latency, bandwidth, and throughput. Okay, these are different terms that we're going to encounter, right? Most of the time, it's good to know what they mean, their differences. So, latency, so time for data to travel, time for data to travel. Example 20 minutes, 20 milliseconds ping. So, it's measured in time. That's the main thing that you see there. Bandwidth, the maximum data capacity that maybe your system can handle. Okay, for example, 100 megabits per second. What is thinking? 100 megabits per second. Throughput, the actual data transferred. So that the bandwidth is different from the throughput. While the bandwidth is the maximum capacity, the data capacity, the throughput now is the actual data that is being transferred. Like um mm, if we're sending something, let's say we're sending a message, right? If let's say you're sending a message to I don't know whether WhatsApp has a maximum amount of let's say text that you can put, but most messaging services have something like that, right? They can write to send a message to someone. Uh-huh. So it does. So whether exceeded or not, right? When sending a message, the WhatsApp doesn't just send only your message alone, right? It sends multiple things. You get it? By the end of the day, all of those things, how much, like let's say if you put their maximum amount of data a user can send plus all of those different things, how much data is WhatsApp actually sending out? And then how much now is that person receiving? Are we getting?
Like it also means like travel when you're traveling from Buya to Yaoundé is 7 hours estimated.
Yeah.
But actually can be maybe
5 30 minutes.
from here to Yaoundé.
You can use more. Yeah, you can do.
5 hours.
Yes. Yes. On the traffic on a Monday morning.
Oh.
On the morning around 3:30 a.m. You leave Buya. You get to Douala around 1 hour. Now.
Okay, and then we can look at the bandwidth as the number of passenger, the number of seats in the bus. We want to use like an analogy
Okay, for what and what?
for the latency because latency is the time for data travel. If you travel.
Yeah.
So I can say from here to Yaoundé is 7 hours. And I can say the throughput that's the actual time it took me from here to Yaoundé was 5 hours.
Yeah.
Okay.
That's what it's
Yeah, go ahead.
Yeah.
And then I'm thinking that the bandwidth can be like maybe the size of the vehicle, 70 seaters. Maybe in our car we had just 50 people who showed up.
So the
Okay.
bandwidth is
For that
70.
particular time, yeah. Yeah.
Yeah. You know, most times 70 does usually take more, right?
It can be
You
very
sit on the stairs. You can be roll actually.
Okay, but VIP sometimes some people don't
No,
show up.
VIP is just VIP is
People don't
70
show up.
70.
okay. high bandwidth is not equal to low latency. Engineers need both for distributed systems. A distributed system is a collection of independent computers or nodes connected by a network that work together to appear as a single unified system to users, coordinating via message passing to achieve a common goal.
So I'm sorry for taking you back
Yeah.
from your analogy now. I don't know, maybe my understanding is wrong. For the bandwidth, I rather understood it like the maximum, like if you're traveling from Boya to Yaoundé, like no matter the conditions of the road, the traffic, if there's an accident, like you cannot exceed 10 hours. That should be like maybe your bandwidth for that analogy, not like the passengers in the bus.
No, it's like how many passengers?
Because they say
Oh,
bandwidth is capacity, the
one is
maximum.
capacity, not time,
Yeah, it has
Like
to capacity. Like what's
more like
the
distance.
yeah, this one is more PM time, right? See 20 millisecond. This one is 100 megabytes per second. Like how much you can send per that time or per second. Let's put it like that.
or like for
Or
any
Megabyte
per
per second is like
interval.
velocity.
Or per interval.
Like megabytes per second can be like the quantity per time. That can be like velocity or something.
Mhm.
So which is medium to speed. It's not just time.
So how many packages can you send per a particular time interval? Or what's the time interval that it takes for me to live from here to there? That's my latency, right? Why? Let's say if I have boxes to carry, how many boxes can I actually carry to that place within that time?
Understood.
Mm. Now you have the maximum data capacity. Then now, what's the actual data transfer within that time? Maybe the like you can say okay, maybe the approximation in case there's some data, something falls, some kind of stuff. By the end of the day, I'll still reach with this amount of data, right? Now you can see okay, that's the throughput. Mm. Are we there?
or can also look at bandwidth like the size of the road. Like this road can only take it's one lane now, or it's
Two days.
two lanes go up, come down.
Yeah.
Then if you go maybe to somewhere like let me say Lagos, Lagos has like four lanes, like four cars can be passing at the same sorry, two
Yeah.
cars can be passing at the same this way,
Yeah.
two
Two
cars that way.
cars.
So that's like the bandwidth, like the size that the
One
that
more like volume.
yeah.
Mm-hmm. Is it the different analogies?
It's better on this one.
Okay.
Thank you.
Where?
See, so no
Okay,
one to reduce our energy.
so let's discuss. You guys should discuss about this high bandwidth. It's not equals. Okay, I'll leave it as assignment, guys. But I want you guys to write it down
No,
and
wait
actually
now.
show
No,
me.
let's just
Wait, let's
discuss.
just
Not
discuss it.
not
Yeah,
assign
no,
a present,
yes,
just discuss
let's
it.
discuss.
Okay, high bandwidth is not equals to low latency. I want to get your inputs.
Okay, latency is the time it takes for data to travel,
Mm-hmm.
and the another bandwidth has to do with the size
Yeah, maximum capacity.
or capacity. So high bandwidth is not equal to low latency.
So in terms of why do I want to speak, you guys should.
I want this
You already said
should be
something.
present purpose.
Okay, I said latency has to do with the amount of time it takes for data to move from one point to another. Why the bandwidth has to do with the size, how much data can move
I think
per time.
because yeah, it's not equal to because Bandwidth is not a measure of speed,
It's a measure of
volume,
volume or
size.
capacity or
You
size.
get the capacity of size.
Yeah.
So if we are saying that it's high bandwidth is equal to there, it's more like we are now saying that bandwidth is equal to speed, whereas it's not equal to speed. So it actually makes sense for high
The
bandwidth not being equal to low bandwidth.
high bandwidth is not equal
No,
to
look at the
No,
high and the
and the
low.
low,
Yeah,
yes.
don't focus on the bandwidth and the
Bandwidth, okay,
latency.
okay, yeah, yeah.
Yeah,
like
High
saying that is
bandwidth.
inversely proportional.
Proportional.
yeah. So the fact that you're sending
The fact that you're
5
sending more
megabytes of
data does
data
not
does not
mean
mean
it
that the
take
time is going to be shortened or
yes.
take less time to reach your destination. Mm,
Yes.
you get it? In terms of network, right?
Uh, okay, if I'm sending you like a video that is like 10 megabytes, then it's going to like take more time for you to download it, something like that.
Non necessary. That's
So
what
that's why
it
it's
says
saying that it's
saying
not,
non
it's not
necessarily the
necessary
case.
Yeah,
take
and
place.
it's not really about the download. It's
It's
about
rather the time to reach
Yeah,
you.
yes
time to
to
reach.
reach you.
Yeah.
Thank you. Yeah, because it's not necessarily about the download or you uploading it. You
Mm-hmm.
get it? Once it's how can I put- once it's uploaded, as in once because when you're saying it's like it uploads first, right? Once it's uploaded, it can be seconds to reach the person before
Or
the
rather,
person.
maybe
Because
upload time is
it
not
depends.
equivalent to file size because bandwidth now goes to the file size.
Bandwidth is not file size. It's the capacity
That
which
can be
that
sent.
size can pass through, or the space which can allow the file to pass through. Yeah, that can be
How
Go and
much?
try and if you ask me tomorrow, I want to
okay.
sorry.
But then, yeah, I think it's not the case because when it gets to um, latency, it's about time which you
It
take to
takes to
receive.
travel, yeah.
And for that information to take to travel, there are various things that may actually, there are various factors one may have to consider. Maybe the signal, the strength of the signal, that kind of thing.
Exactly.
Yeah,
Like
the
yeah,
network
you're just trying to say
itself.
it's not that you cannot say no because I'm sending more data to the person, me that's why it's slow. No, no. It's just like when you have issue with network, your first thing will not be what am I sending to a
What?
person, right?
Yeah, yeah,
It should not even be because that should not even be an issue.
yeah. We
Are
are
we
not
there?
receiving messages. You not be like it's because it's a video.
Yes,
It's
that's why
because
it
it's
has
a text. Yeah.
is
You
delayed.
start thinking
No,
about maybe service provider,
exactly. Maybe the
maybe
spot where I'm standing, then
spot where you're
you
They
standing.
start
use the
thinking of
window.
things like
Yeah,
yeah, things like that.
you want to restart your phone for anything, voila.
Guys,
Okay.
I don't think you
There
have
is,
ever.
can I ask a question? This is like an aside. Okay, I was in Yaoundé recently, and I discovered that okay, like for example, in Yaoundé, the internet is very fast.
Smooth.
I mean, the same bundle, the same data bundle, nothing changes. I mean, the internet is very fast. The same thing would have, I can take like maybe say 30 minutes to do here, but I was taking like seconds to do in Yaoundé. So what's the problem? Because like for example, if I here in Boya, I can maybe stand here and I'm able to see BT stations around. Like I can see one at Moliko, there's another one at Street. I think Street One or Street Two like that. There's another one
What
at
station?
BT stations.
Oh, okay,
What's
okay.
that?
Like how do I explain it?
BTN.
Like these
This,
big things that
this
stand
those
up like
are
that, they put
antennas.
Okay,
rounders,
okay, okay. Those
antennas.
antennas
Yeah,
Yeah, that
that
is
boost networks.
yes.
yeah.
You can also see one at the around the regional hospital. But now the where I was staying, I could not
You not
see
Not
see
even
anything.
one.
Yeah.
So what's why do we have low, I don't know what to say. Why don't we have
Okay, why
as
don't we have
As
as
much
smooth internet as it
as
is in
as it is
Yaoundé?
yes,
in
because
Yaoundé.
the size of Yaoundé is greater than Boya. So what's the problem?
Yeah. Just like light, the same thing with light usually constant there than here.
Ah, no, let's not go
Let's
there.
exactly.
Yeah. So you know, it's still because
let's
of.
know.
I mean, another thing should be the environment. Maybe they concentrate the signal around that environment because of the
But
people
I'm
around
saying
it.
that for example now, if I want to, how do I put it? Like the reason why we have so many BTS stations because of the population now,
I get you.
so that to increase maybe the bandwidth or the, I don't know if I'm explaining it
Okay,
well.
I get what
No,
you're
I
saying. But
can
then
get you
the
very
BTS
well.
station can still be there,
Mhm.
but
But is
the
it that the ones
concentration
here
of
in
the signal
Boya are not working?
they might still be okay. Okay, it's like let me look for hosting a 2G network and hosting a 5G network. You get it? Maybe the signal this side is very weak compared to that in Yaoundé of course the dignitaries are around there.
That's the question. The question. Okay, the
I,
I
I,
think it's intentionally made so.
I
Not
just,
okay.
necessarily because of us, but it's intentionally made so
I
from the
just,
provider
The
company.
service provider.
Yeah. From the service provider
it's
company.
like just the management.
Yeah, it's just a
Yeah,
management.
because
It's just a
normal, like you
management.
said, right? We have that. Why should I go to Yaoundé and it's stronger? And yeah, it's not stronger.
Because
It's
if you
not
go to
it's
Yaoundé,
something
they
that
don't
you
do even
say.
use Starlink.
It's not you say okay, maybe it's because of climate.
Really?
Thank
They don't use Starlink. There's no need now because their
Yeah,
internet
the
is
internet is
fast.
very fast.
It's not
And
if it's something that you say okay, maybe it's because of
CC
climate
clearly.
or no. So that's things which if you manage them well, they should act the same way
It's just the same
everywhere.
thing we lied to.
you. It's
Yeah,
geographic.
it's the same thing.
It's really geographic
it cannot
location.
be geographic location because
Ah,
Yaoundé is
I know
really
geography.
like we're just one plane,
It's
like one.
just mismanagement or allocation of resources. It's not evenly distributed.
Yeah.
Resources are not evenly
Mm,
distributed.
network is one link. There's traffic congestion.
So firewalls and security basics. So definition. So
Okay.
firewalls allow or block network traffic based on IP, right? Port or protocol. I mean, there are moments when people be like, use VPN, use VPN, use VPN, VPN is passing. And the other times, we don't care about using VPNs again. So, I mean, all firewalls will allow access and block access based on IP. We say, okay, we use VPN because it's going to show that you're from a different country. Practical use cases protect servers from unauthorized access, control which services can communicate, cloud security rules, AWS security groups, GCP, firewalls. Yeah, so that's what firewalls are meant for. Load balancing, high availability, distributes traffic across multiple servers to prevent overload. Example, user. So you see it passes through the load balancer and then load balancer now chooses which server to send you to. Are we there? So benefits. So the main thing you should know is most of this stuff when building apps, it's not as if they're already there by default. You get it? You, the software engineer, should be the ones who like based on what we are building, we need a load balancer. We need to have these multiple servers. We need this. We need firewalls. We need that and that and that. You get it? It's not if by default they're all there for you. No. Fault tolerance. Better so benefits of a load balancer, right? Fault tolerance, better performance, horizontal scalability. Analogy like multiple checkout counters in a supermarket. Like come and see. I mean this line is long. I go to this other guy. Yeah. Cloud networking basics. Virtual network, VPC. Virtual private cloud. Private network in cloud. Subnets, network segments inside a private network. Security groups or firewalls or we talk about allow or block traffic. Internet internal versus external traffic, node to node versus internet access. Practical networking mental checklist. So when debugging or designing, is the service reachable? So ping, trace route, these are different commands, right? That you can use. Alright, guys, here. Let's say if we ping google.com. So yeah, that's it. You went to Google and got back. So you can see this is the latency, right? 93 milliseconds, 93 milliseconds, 90. So this is like the first packet that is sent. So reply from that server, time that reply from that server. So you can say what? We ping google.com, but you have to change it to what the IP address of the server, right, where you can find it. And then with 32 bytes of data, that's like how much data it's sending, right? Then now
Which is using by the IP6.
yes, IP version 6, right? So it sent, so replied it in 93 milliseconds. So it send, send. It's like, okay, ping statistics for this server. Packet sent 4, received 4, lost 0, 0% loss, approximate round time. So minimum 93 milliseconds, maximum 99 milliseconds, average 95 milliseconds. So
So
these are
ping is like a request.
ping, 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 like test, like a request, like you said, yeah. So it's a way in which we use to test different whether my node, this node is reachable in the network. Are we there? So all of us are in network. If you give me your IP address, I can ping you and see whether my laptop can connect to you. Are we there? There's also trace route. Trace route. I think this one. Let me see. Does it? Let's see. Instead of ping, we use trace route. Oh, okay. That's. I think trace route is what they use in DC. Trace route is Linux, Ubuntu, right? The Ubuntu command. But in Windows, we use the trace, like short form of trace route. Yeah. So you see, it's actually telling you the different routers that it hits before even reaching the the google.com server. So it's like, okay, I've reached here, I'm here now, I'm here now, I'm here now, and stuff like that. Are we there? Inside, I think most of the time when you use it, you can even see like MTN's own router, that from MTN now it goes across now to the rest of the world. Because when we send something, it has to pass through MTN's own gateway. So we call it a gateway, right? From it now it goes.
Yeah, it's passing through the stand
Exactly.
since that's what we're using.
Yes. Okay. Is the correct port open? So maybe you want to access a particular port, right? So remember, it reaches your device. Inside that device, you want to access this port. Are we there? Yeah. Is the IP correct? So you are checking all of those things, right, while building or debugging a network. Are DNS and host names resolving? Like for example, if we ping this and what an issue, meanwhile we start debugging, right? What's the issue? Why is this? Why is this? And all of those stuff. So this is what trace route also comes, because if let's say after ping it did not go, trace route now will tell us where it stopped. Are we there? Yeah. Um, is bandwidth sufficient? Are firewalls or security groups correct? Is latency acceptable for the application? Then we'll have a summary here. Networking is foundational for software and data engineering. Everything in distributed systems, APIs, or cloud relies on it. Engineers must understand IP ports, protocol basics, client server flow, latency, throughput, bandwidth, firewalls, load balancers, cloud networking. Deep understanding equals what? Easier debugging, better system design, scalable infrastructure. Ah,
So semesters work in effect.
that's a good one.
Yeah,
So put me
Well, let me stop my recording. I was still recording. Okay, yeah. Stop recording. Are you sure you would like to stop? Yes.